Now let us see the students. Next topic is work done by variable force in one dimension. Last time we have discussed about the work done by variable force in 2 or 3 dimensions. And the equation was given by W equal to integration of vector F dot dl. And as you know, what is variable force? Either magnitude of force goes on changing, direction remains constant, or direction goes on changing, magnitude remains constant, and sometimes both magnitude as well as direction goes on changing of the force. Then such a force is known as variable force. But here we have to discuss work done by variable force in one dimension, so automatically it is indicated that direction of force here remains constant. And we select that one dimension is supposed to be x-axis. That means in the x direction, the force is continuously acting. So as the direction is constant, then which other data can go on changing? Only magnitude. So here the magnitude of the force in x direction acting on a particle either continuously goes on increasing or decreasing. Out of these two, at least one is happening. But direction remains constant, then it is the topic of work done by variable force in one dimension. We are supposing if an object is placed on a one horizontal surface, from back side we are going to be applying the force, so that at every moment its magnitude goes on increasing. That means suppose at time t equal to 0, the force applied is 5 Newton, at 1 second 10 Newton, at 3 seconds 15 Newton, at 4 seconds 25 Newton, at 5th second 30 Newton, like this one. So as the magnitude of the force until its motion continue goes on increasing, then such a force is said to be variable force in one dimension, and this is the topic here. So here we are considering if the motion of a particle is in one dimension, say x-axis, and magnitude of the force acting on a particle is in this direction goes on increasing, then work done W equal to, as we have seen last time, it is integration of F dot dl, the same formula. So let the particle goes from initial position A to final position B. Corresponding to initial position A, there will be definite x coordinate. Corresponding to final position B, there will be another definite x coordinate, and we are selecting this x coordinate are x1 and x2 for the position A and position B. And now if we draw the graph of f versus x, the nature of the graph could not be a straight line, but it will be a curved line, because the force is on the y-axis, displacement is on the x-axis. Here x1 is supposed to be equal to 10 centimeter initial position, x2 is equal to 50 centimeter final position. So from 10 centimeter to 50 centimeter, magnitude of force goes on increasing. Here I have written at x1 equal to 10 centimeter, suppose the force is 10 Newton, then value of the force goes on increasing up to becoming 50 Newton. So like this one, corresponding to value of f, fx and x, if you draw a graph, the nature of the graph will be like this one. So here a should be replaced by x1, b should be replaced by x2, dl should be replaced by dx, and because of force and displacement being in same direction, angle between them is 0. So f dot dl can be written as f dx cos 0, and that's why it is integration of f dot f dx, and this a is replaced by x1, b is replaced by x2. So final equation of w is equal to integration from x1 to x2 of f into fx into dx. So if x1 and x2 are the x coordinate of the points a and b as shown in figure of, or as shown in the graph of fx versus x, then w equal to integration from x1 to x2 of fx into dx, or you can write it is simply f into dx, where f is the function of x. F is the function of x. Now it can be seen from the graph that work done during a very small displacement dx. So here during the motion from 10 centimeter to 50 centimeter, during the motion from x1 to x2 centimeter, if I consider a little very small displacement, that small displacement lying in between any value, that may be 0.5 centimeter, 0.3 centimeter, 0.2 centimeter, 0.1 centimeter, then corresponding to that displacement, there should be a width, and that width is denoted by symbol dx. And as this displacement is very small, this width will be very small, and corresponding to that force we consider as remaining constant for a very small displacement. That means let a particle is going from 10 centimeter to 10.5 centimeter, or you may consider any other value, 20 centimeter to 20.2 centimeter. So 20.2 minus 20 becoming 0.2 centimeter. And during this very small displacement like 0.2 centimeter, which will be the force, that force would be considered as constant. And as that force is constant, then what will be the work done? Work done equal to simply F into dx. So here, the same point is here. It can be seen from the graph that the work done during a very small displacement like dx is F into dx. And it is equal to what? It is equal to the area of this small rectangle strip. So what will be the length of this strip? The length of this strip is equal to the constant force, and width of the strip equal to dx. That means F into dx is nothing but the area of this rectangle strip. As you know, for any rectangle, what is area? Area equal to length into breadth. So here length is equivalent to force and breadth is equivalent to this width dx. And that's why it is equal to the area of that small rectangle strip. Now if this entire path from x1 to x2 is going to be divided into all such small strips, from starting से यहाँ से लेके आप ये पहली स्ट्रिप इतनी ले सकते हैं, from x1 से इस तरह से, like this one. So this is one strip, this is another strip, this is third strip, this is fourth strip, this is fifth strip, like this one. तो x1 से लेके x2 तक की ऐसी छोटी छोटी स्ट्रिप्स आप कंसिडर करो, एंड एवरी स्ट्रिप के लिए वैल्यू ऑफ द फोर्स फ्रॉम दिस पॉइंट यू कैन कंसिडर एज कांस्टेंट. जैसे यहाँ के लिए 10 न्यूटन, यहाँ के लिए थोड़ा सा 10 से ज्यादा, ये थर्ड स्ट्रिप के लिए इससे भी ज्यादा, इस तरह से फोर्स आता रहेगा. तो वो फोर्स एंड ये स्मॉल स्ट्रिप की विड्थ का प्रोडक्ट इज इक्वल टू वर्क डन. सो टोटल वर्क डन विल बी इक्वल टू व्हाट? So this suggests that the total work done for the motion of a particle from x1 to x2 can be obtained by summing up the areas of all such small strips. तो पहली स्ट्रिप का एरिया प्लस दूसरी स्ट्रिप का एरिया, तीसरी स्ट्रिप का एरिया, चौथी स्ट्रिप का एरिया, पांचवी स्ट्रिप का एरिया, छठी स्ट्रिप का एरिया. तो इस तरह से जितनी भी स्ट्रिप x1 से x2 तक मिलती है, तो ये सारे स्ट्रिप्स का एरिया और वो एरिया का सम आपको क्या देगा? टोटल वर्क डन ड्यूरिंग द डिस्प्लेसमेंट ऑफ ए बॉडी फ्रॉम x1 टू x2. तो अब आपको यहाँ पे कौन सा सी, तो यहाँ पे सब समेशन यूज करना पड़े, एंड समेशन क्या होगा? देन रिजल्ट इनटू इंटीग्रेशन, बिकॉज दिस ईच स्ट्रिप इज एज पॉसिबल एज वेरी स्मॉल. In other words, this work done is equal to the area under the graph of fx versus x between x1 and x2. तो ये अगर आपको कैलकुलेशन नहीं करना है तो आप ग्राफ के ऊपर से सीधा ये पूरे ग्राफ का एरिया फाइंड करें. तो पूरे ग्राफ का एरिया मतलब कैसे फाइंड करेंगे? तो दिस काइंड ऑफ द ग्राफ इज डिवाइडेड इनटू द वेल नोन फिगर्स. वेल नोन फिगर्स मतलब आप यहां से इसको पूरा एक ये रेक्टेंगल ले सकते और ये बाकी का रिमेनिंग राइट एंगल ट्राइंगल ले सकते. तो इस तरह से यानी कि रेक्टेंगल का एरिया प्लस ये रिमेनिंग पोर्शन का, लाइक दिस वन, राइट एंगल ट्राइंगल का एरिया, दैट विल बी इक्वल टू व्हाट? द एरिया अंडर द कर्व ऑफ fx वर्सेस x. ये पूरा a से x1, x1 से x2, x2 से b, b से a पे वापस आने वाला, तो वो जो पूरा पोर्शन का एरिया है वो एरिया किसके बराबर मिलेगा आपको? वर्क डन के बराबर. That means in other words, this work done is equal to the area under the graph of fx versus x between x1 and x2. So here, this was the topic where the magnitude of the force goes on changing and direction remains constant. Now this is another case where the magnitude of the force remains constant and direction of the force goes on changing. So I am considering this is another curved path from the along which the particle is moving from 1 to 2 in xy plane. And here at because of this is a curved path, at every moment in the direction of tangent you can consider as a force is there. So direction of the force goes on changing, but magnitude suppose remains constant. Then in that case, what will be the work done? So here, now if the magnitude of the force remains constant, but its direction goes on changing as shown in figure, then for a particle moving from a point 1 to point 2 along this curved path, from a particle फ्रॉम ए पॉइंट 1 एंड पॉइंट 1 मतलब किसका, इसका पोजीशन वेक्टर r1 एंड पॉइंट 2 जिसका पोजीशन वेक्टर r2. तो फ्रॉम ए पॉइंट 1 हैविंग पोजीशन वेक्टर r2 टू अदर पॉइंट 2 हैविंग ए पोजीशन वेक्टर r2 अंडर द इफेक्ट ऑफ सच अ वेरिएबल फोर्स. अब यहाँ पे वेरिएबल फोर्स कैसा है, उसका डायरेक्शन एट एवरी पॉइंट ऑन दिस पाथ रिमेन्स इन द टेंजेंट डायरेक्शन. That means the direction of the force goes on changing, but magnitude remains constant. Then such a variable force is there. Then work done during the motion from 1.1 to point 2 is W12 equal to again integration. तो point 1 का position vector R1, point 2 का position vector R2. So you can write integration from R1 to R2 of vector F dot dr. So what will be this dr? Dr is displacement vector. So displacement vector from 1 to 2 according to method of triangle. This is vector r1 plus vector dr equal to vector r2. So dr will be equal to what? You will get r2 minus r1. So you can replace this dr by r2 minus r1. So this w12 equal to f dot vector r2 minus r1. That means it is the scalar product of force and displacement vector. So this is the topic where magnitude of force remains constant, direction goes on changing. This is a topic where the direction of the force remains constant, magnitude goes on changing. Now the next topic is work energy theorem for variable force in one dimension. We have studied work energy theorem, that is W equal to delta K. The same equation we will obtain here. Now for not constant force but for variable force, and वो भी variable force कौन सा, in one dimension. In one dimension that means here the magnitude of the force goes on changing but direction remains constant. That direction is supposed to be x direction. So here if a body of mass m have a velocity v, then its kinetic energy is given by, we know k equal to what, 1 half mv square. Kinetic energy equal to 1 half mv square. So now if you take the change of this kinetic energy with respect to time, that means the rate of change of kinetic energy is dk by dt equal to d by dt of right hand side, it is 1 half mv square. In this derivations 1 half is constant, mass is constant, so it will come outside. So 1 by 2m into derivative किसका, d by dt of v square. लेकिन यहाँ पे v square के इक्वेशन में कहीं पर भी t नहीं है, इसीलिए यहाँ पे चेन डेरिवेटिव का कंसेप्ट आता है. मतलब v स्क्वायर में v का पावर 2 है, 2 आगे आएगा एंड ट्वाइस एक पावर रिड्यूस होगा तो ट्वाइस v होगा, और ये v का फिर से आपको डिफरेंशिएशन लिखना पड़े. तो एक्चुअली दिस यू हैव टू स्टडी इन मैथमेटिक्स, बट इन अर्लियर चैप्टर यू हैव ऑलरेडी स्टडीड इट. So this is 1 by 2m into twice v into dv by dt. But what is dv by dt? We know it is equal to what? Acceleration. That's why here 2 will be cancelled. You can write mv into dv by dt, and mv into dv by dt के बदले में acceleration a. Then you can write mass into acceleration in one bracket. So mass into acceleration into v, and mass into acceleration equal to what? Force. So it is equal to force into velocity. So dk by dt is equal to force into velocity. But this velocity is in which direction? It is in x direction, and because of which again you can use the mathematical concept velocity v equal to dx by dt. अगर यही velocity 2 dimension में होता xy plane में, तो that velocity can be replaced by dr by dt. अगर यही velocity y direction में होती तो that v can be replaced by dy by dt. लेकिन यही velocity x direction में है, that's why v can be replaced by dx by dt. तो f into dx by dt. From both the sides denominator dt is cancelled. Therefore you can write dk equal to f into dx. लेकिन हमको तो कौन सा इक्वेशन चाहिए? वर्क डन W इक्वल टू डेल्टा के. तो नाउ हियर अब dk की जगह अकेला k चाहिए. अकेला k चाहिए मतलब यहाँ पे आपको इंटीग्रेशन करना पड़े, और वो भी इंटीग्रेशन कहाँ से कहाँ तक? इनिशियल काइनेटिक एनर्जी से लेके फाइनल काइनेटिक एनर्जी तक. इनिशियल काइनेटिक एनर्जी कहाँ पे मिलेगी? एट इनिशियल पोजीशन xi, एंड फाइनल काइनेटिक एनर्जी कहाँ मिलेगी? एट फाइनल पोजीशन xf, बिकॉज दिस इज द टॉपिक where motion is in one dimension, and that one dimension we are selecting as a x-axis. So now on integrating from initial position xi to final position xf, we get integration of dk, और वो integration of dk कहाँ से कहाँ तक? ki to kf. Ki is initial kinetic energy corresponding to initial position. Kf is final kinetic energy corresponding to final position xi. तो on the right hand side, तो right hand side किसका, इसका integration of f dot dx from xi to xf. तो integration of dk becoming only k, लेकिन k की लोअर लिमिट कौन सी है, ki, अपर लिमिट कौन सी है, kf, इसलिए क्या लिखेंगे डायरेक्टली सब्ट्रैक्शन kf minus ki equal to, and we know this is the formula of what, work done in one dimension, therefore kf minus ki equal to w, where ki and kf are initial and final kinetic energies corresponding to xi and ff. So kf minus ki, this is the change in kinetic energy from final position to initial, so denoted by symbol delta k, and delta k equal to w. So this is the equation of work energy theorem. Now we have to study the one example, example number 6.2. What is given in this, in the textbook? If you read it, then you will get it. There is a one raindrop is falling, and this raindrop having a mass equal to 1 gram. 1 gram, that is 10 raised to minus 3 kg. And when it hits with the ground, then its velocity is 50 meters per second. What does it mean? So when it come out from the cloud, you can consider its initial velocity is 0. When it touches the ground, its final velocity, so that final velocity is 50 meters per second. Now what is the height of that cloud? The height of that cloud is given equal to 1.0 kilometer, equal to what, you can write 1000 meter. What you have to find? You have to find two things. Number one, work done by the gravitational force. Because of this raindrop is coming down under the effect of force of gravitation, so work is done by the gravitational force. And second one is work done by the unknown resistive force. Actually what happening, when from the cloud this kind of the raindrop is coming down, then on this raindrop there are two kind of the forces acting. One is gravitational force, and at the same time in a direction opposite to that of its motion, the resistive force. The resistive force का मतलब क्या, जैसे कि आप अपने टू व्हीलर पे जा रहे हैं हाईवे के ऊपर, तो हाईवे पे अगर टू व्हीलर की आपकी स्पीड बहुत कम है, तो सामने से जो फोर्स लगता है किसका, एयर का, वो बहुत कम मैग्नीट्यूड का है. आप हाई स्पीड से जाओगे तो सामने से एयर का फोर्सेस लगेगा, वो ज्यादा स्पीड का होगा. तो वो जो फोर्स लगता है बाय एयर ऑन योर बॉडी is always in a direction opposite to that of your motion, and that force is known as what, resistive force. So on this raindrop there are two kind of the forces acting. One is gravitational force in downward direction, so this gravitational force is in the direction of motion, and this resistive force is in a direction opposite to that of its motion. So यहाँ पे work done by gravitational force will be positive, and work done by this unknown resistive force will be negative. Why? Because here the force and displacement are opposite to each other. Here the force and displacement are in the same direction. So one work will be positive, another work will be negative. So here you see, we have to calculate the work done by unknown resistive force and work done by gravitational force. So here suppose the raindrop have initial velocity is 0, because it is considered as at rest when it come down from the cloud. तो जिस मोमेंट पे वो क्लाउड से बाहर निकलता है उस मोमेंट पे यू कैन कंसिडर इट्स स्पीड इज 0, एंड जैसे नीचे आता जाएगा इसकी स्पीड बढ़ती जाएगी बिकॉज ऑफ ग्रेविटेशनल फोर्स, एंड व्हेन इट टचेस द ग्राउंड देन फाइनली फाइनल वेलोसिटी इज गिवन. तो हियर एज इनिशियल स्पीड इज 0, then you can say its initial kinetic energy is also 0. So change in kinetic energy of raindrop is final kinetic energy minus initial kinetic energy. Final kinetic energy kf is equal to 1 half m v square, where v is final velocity. Initial kinetic energy will be 0 because initial speed is 0. So 1 half m v square minus 0 equal to 1 half m v square. This is the equation of delta k. Therefore you put the value of mass, put the value of final speed. So 1 half into mass of the raindrop is 10 raised to minus 3 kg. Final speed was 50, so 50 square. You calculate, you will get the answer 1250 into 10 raised to minus 3 joule. That means it is 1.250 joule. तो ये क्या हुआ? Change in kinetic energy. Now use the work energy theorem. Change in kinetic energy equal to total work done. तो ये total work done में दो वर्क है. One is work done by gravitational force, another is work done by resistive force. So you can get the sum of these two work will be equal to total work done. So work done by gravitational forces, now we can write Wg इक्वल टू व्हाट, फोर्स इनटू डिस्प्लेसमेंट। अब यहाँ पे देखो कहीं पर भी नेगेटिव साइन नहीं है, कहीं पर भी थीटा नहीं है, क्यों? बिकॉज फोर्स एंड डिस्प्लेसमेंट आर इन सेम डायरेक्शन। तो सिंपली प्रोडक्ट ऑफ फोर्स एंड डिस्प्लेसमेंट, कौन सा फोर्स? ग्रेविटेशनल फोर्स यानी मास इनटू जी, एंड डी यानी क्या? हाइट ऑफ दैट क्लाउड फ्रॉम द ग्राउंड। तो mgh, पुट द वैल्यू ऑफ m इज 10⁻³ वी टेक g की वैल्यू अप्रोक्सीमेटली 10 एंड h इक्वल टू कितना था? 1000 मीटर। तो आंसर इज 10.02। तो wg आपको मिल गया। अब आपको wr कैलकुलेट करना है। तो नाउ रेजिस्टिव फोर्स ऑफ एयर एक्ट्स ऑन द रेन ड्रॉप इन अपवर्ड डायरेक्शन एंड वर्क डन बाय इट इज सपोज टू बी इक्वल टू wr। देन टोटल वर्क डन इक्वल टू क्या लिखेंगे? wg प्लस wr। अकॉर्डिंग टू वर्क एनर्जी थ्योरम दिस डेल्टा k इक्वल टू व्हाट? wg प्लस wr। तो डेल्टा k इक्वल टू टोटल वर्क डन एंड टोटल वर्क डन इक्वल टू wg प्लस wr। Therefore, डेल्टा k की वैल्यू 1.25, wg की वैल्यू 10.0 प्लस wr। तो wr इक्वल टू क्या? ये 1.25 को किस में से? 10 में से, यानी कि wr इक्वल टू इधर आएगा तो 1.25 माइनस 10, तो आपको wr इक्वल क्या मिलेगा? -8.75 एंड इट इज नेगेटिव। व्हाई इट इज नेगेटिव? बिकॉज द रेजिस्टिव फोर्स ऑफ एयर इन वर्टिकली अपवर्ड डायरेक्शन, मोशन ऑफ रेन ड्रॉप इज इन डाउनवर्ड।